but this is your 1 through 80 test, your quarterfinal review. So if you remember from the list I just gave you, I think question number 1 actually did show up on the list, right? So this first question says, what is the distance between 7.5 and -6, -5? Okay, this is question number 1 on your review. Okay. We should have 2 methods for finding this solution, right? Okay, what's solution number 1? Distance formula, okay? Somebody tell me what the distance formula is. Go ahead. So it should be x2 minus x1, okay? Squared. y2 minus y1 squared, okay? We just want to make sure that we understand the difference between x2 and x squared, okay? Yes, this is absolutely right, okay? So let's actually throw this information in here, okay? But to make our job easier, let's go ahead and label these 4 numbers as either x1, y1, x2, y2, okay? What is 7? x1. Okay, what is 5? y1. What is -6? x2. And y2. Okay, that'll make your job easier. Okay, because now all I have to do is substitute numbers into my equation, right? All right, what was x2? -6 minus x1, which is 7 squared plus, what's y2? -5 minus what? 5 squared, okay? I'm going to keep going through here. What's -6 minus 7? -6 minus 7. Negative what? 13. -13. -13. We're going to leave that inside a set of parentheses with the squared out here, okay? What's -5 minus 5? -10 squared, okay? We're just simplifying as we go. It's not to say that you can do some of these steps combined. What is -13 squared? 169, good. Okay, not -169. Okay, what is -10 squared? 100. Okay. Okay, we're going to drag this down. So we have the square root of what? 269. Okay? Square root of 269. I'm going to actually pull up my answer key here. Make sure that we stay on track. Okay, what is the square root of 269? 16.4. Okay? And if we look at our question, it's going to say round to the nearest tenth. Okay, so it does expect it to have a decimal answer. It does not want you to leave it as the square root of 269. Okay? Is there another way to do this? Yes, what is that other way? Plug it, what? Yeah, you're saying, could I just do all of this in the calculator in one shot? Yeah, that doesn't, but that's not necessarily a different way, right? You're still having to write this out and then plug it in your calculator to get your answer, but you're still using the distance formula, okay? What I mean by a different method is a different theorem, okay? We have the distance formula and we have a Pythagorean theorem, right? Pythagorean theorem is going to end up taking the distance between my x's, right? What's the distance from 7 to -6? 13, right? 13. And the distance of my y's, 5 and -5, is 10. Notice that we're using the same numbers that we found here in step 3. Equals c squared. That's 169 plus 100. That's 269 equals c squared. Square root both sides. We still get 16.4 equals c. It's really not I know it looks like it's fewer steps, but like the whole 13 squared plus 10 squared, we are doing the same math that step number 2 includes in the distance formula, but we're doing it in our heads. If you aren't solid in being able to find distances between points, especially the differences between positive and negative numbers in your head, then I suggest that you don't use the Pythagorean theorem. You use the distance formula. Does that make sense? Okay. All right, any questions on that? All right, because I think you will remind me here which questions showed up on our list and which ones did not. But number 1 was on our list, which means I'd want to know how to do this. Okay? Number 2. Is number 2 on our list? Yes. Okay. So I'm going to give you a formula to start off with. Okay? It's one that you're going to want to know on your test. We use this for different things. It's not always money, although a lot of times it's money. But amount equals principal times 1 plus rate over number of times compounded to the rate times time. Okay? If you need to know what one of those variables means, let me know. Rate is going to be given as a decimal. This n is going to be number of times it's compounded in a year. Okay, so let's look at this. Suppose we deposited $1,000, okay, in a savings account. How much will be in the account in 5 years if the account earns interest at a rate of 2% compounded quarterly? All right, so we are searching for A. Right? We want to know what our amount is going to be. What is my principal? 1,000 times 1. What is my rate? What's that? 0.02. Okay? Watch out on that because 0.2 is 20%. So if we're at 2%, we need to go back another. Okay? 0.02. How many times am I compounding this in a year? 4 times. How did you know it was 4 times? Quarterly is a fourth, okay? So 4 times in a year. All right, so we're going to take, oh gosh, I think I might have, it's in up here, I'm sorry. Yep, so it's going to be 4 times 5 years, okay? So that's what we want to do. We know we can simplify some of this. We know we're going to take that to the 20th. Okay. So a lot of this we can plug in our calculators. We can take 0.02 and divide that by 4 and then add 1 to it. Okay, to kind of help ourselves out here. So I'm going to do that. 0.02 divided by 4 is 0.005 plus 1. So we're getting 1,000 times 1.005 to the 20th. So I can take my 1.005, which I have in my calculator, to the 20th, okay, times 1,000. And I should get $1,104, and I'm going to say 90 cents. Yep, and that's what they do. They round it up because it's actually, it comes out in your calculators 1,104.895. That 5 rounds that 9 up. As it does, it rounds the 8 up. So when we have money questions, you want to make sure you round to the 100th. Okay? Questions on number 2. Okay. Be prepared that the question on the test may not be a money question that it's asking you. Okay? Now let's see, I want to look at, okay. And it may not be, you know, it's going to say how much money do I want to get back. It may be how much money do you have to pay after so many years. That's kind of a hint. Okay? So if somebody borrows money, okay, that same amount goes here. Okay, if I borrow so much money, that's still my principal. Okay, and the bank charges me a percent. That percent still goes up here where my 0.02 is. Okay? It may not be quarterly. It could be monthly. If it was monthly, what number would go down here? 12. If it's monthly, if they're charging me monthly, then instead of a 4, I'm going to have a 12. Okay? And then that 12 will go up here with my exponent. Okay? And let's, for a number of years, I'm going to take those years and put it where that 5 is. Okay, does that make sense? I'm trying to give you some hints over what the question on the test actually looks like. Okay, without giving too much away. All right. Number 3. Okay, is number 3 on our list. Okay? I'm going to try to look and see which question it matches up with. I'm going to say it matches up with one of our very last ones. And that it does. Huh? Okay? Yeah. All right, so number 3. Now, I'm going to warn you, on the test, it will have variables. Okay, on this question, it's 3/8 plus 1/2 over 2 plus 2/7. Okay, in your question on the test, it will have variables in here. But the process is still the same. Okay? Now, order of operations means that everything that happens in the numerator is grouped. Okay? Everything that happens in the denominator is grouped. Even though this is division, right? When we think about order of operations, we know that division happens before addition and subtraction, right? But my numerator and my denominator are grouped. So in order of operations, we do grouping first, correct? Yes? I can get heads wobbling up and down. Okay? So what we're going to do is it doesn't matter if we do the top or the bottom, but we do need to do both of them before we actually apply our division. So 3/8 plus 1/2. What do I have to do in order to add those two fractions? Common denominator. What is the common denominator of these two? 8. 8. 16 works, but 8 works before 16, right? All right. What do I have to do to get the common denominator of 8? Multiply what? Multiply what by 4 and 4? 1/2 by 4 over 4, right? So that's giving me 3/8 plus 4/8. What's 3/8 plus 4/8? 7/8. Okay? So I have 7/8 divided by. Now we have to do 2 plus 2/7. Okay, let's pick a different color here. 2 plus 2/7. Well, what is 2 as a fraction? 2 over 1. Okay, that's going to help me out here a little bit. Now I have two fractions where I need to get a common denominator. What's the common denominator here? 7. What do I have to do that? Multiply 2 over 1 by 7 over 7. Okay, 7 times 2 is 14, so I'm getting 14/7 plus 2/7 is what? 16/7. So I have 7/8 divided by 16/7. Can I divide by a fraction? No, I cannot. Okay? So let's pick a different color here. I cannot divide 7/8 by 16/7, but what can I do? By the reciprocal. So multiply 7/8 by 7/16. Okay? 7 times 7 is 49. What's 8 times 16? What's that? 148. 128. Okay? And that's it. You can check. You can put 49 over 128 in your calculator, hit enter, hit math, fraction, enter, and I believe you're still going to get 49 over 128. Okay? It's going to be a little different on the test. Like I said, it's going to have variables instead of being all numbers. Okay? All right, number 4. Number 4 wind up on our list? Okay, number 4. I want to see where it shows up. Okay. It's a little different on the test, but it's going to be worded a little bit differently. says use synthetic substitution. In fact, I don't know if 4 is a really great example of the question I was thinking of, to find f of negative 4. So if I have x to the 4th minus 5x squared minus 7x minus 5, all right, and I want to find f of negative 4, what am I going to do? What's that? Plug in negative 4 for every location where x is. Okay? Can you guys, I mean, you can do that much in your calculator, correct? Okay? Now, just by way of kind of fast forwarding through this, you should get 199. Okay, but like I said, I really don't think that number 4 fits the question that I'm thinking about wholly. So I'm going to try to come up with something that might work. Let's see. I'm going to create a new question here that matches, hopefully, what we have. Okay? We want to divide 10x plus 12x cubed minus 16. Okay? We want to take this and divide it by x minus 2. Okay, can we do that? Okay? Talk to me. How? Synthetic division. Tell me about synthetic division. I know this much. I know synthetic division starts like that. Okay? Tell me what to do after that. 10 here. 12 here. Negative 16 there. Okay? What goes here? 2. Why not negative 2? Because we're solving for x, right? X equals 2. All right, what happens next? Bring down the 10. Okay, now what? 2 times 10 is 20. Okay. Add it. 32. And get 64. Okay, subtract 16 from 64. What am I getting? 48. Okay. Let's see. Now I want to, it just says divide. It didn't ask if x minus 2 is a factor. It just wants it divided. But what do I do with this 10, this 32, and this 48? Now, I'm going to tell you now what you did wrong. Okay. You didn't plug in what? I didn't put it in order. You didn't put it in order? And when we go to put it in order, there's something else we're going to need to do. Okay? Tell me about the order. Okay, what should go first? 12. What should go next? No. A 0. Why a 0? Because there's no x squared. Okay, now what? Now a 10, and now a negative 16. All right, let's start over. Okay, now what? Bring down to 12. 24. 24. 48. 58. 116. And 100. Is that right? Now what do I do with the 12, the 24, the 58, and the 100? 12x squared. Why x squared? Why not x cubed? Right, because I'm factoring an x out of it, right? I'm down an x, so I'm getting a 12x squared. Now what? Plus 24x plus 58 plus 100 over x minus 2. Okay? Not over 2. Okay? Over x minus 2, because we're originally dividing by x minus 2. Okay? All right. So sometimes making a mistake helps us that much more, because how many of us would have made the mistake that we made but made it on the test? Probably a lot of us. Okay? So hopefully that's a learning moment. And do we see now why the review question really didn't match up or prepare us very well for that test question? All right, so hopefully we appreciate Mr. Wilcox recognizing that and helping us out. Okay? All right, number 5. It's number 5 on our list. Yeah, it is? Okay, great. And this one I feel pretty good about, I think. It's going to be different, but it's going to involve the same principle. Okay? Meaning, what I mean by same principle is that the question on the test won't be a cylinder, but it will be a 30, 60, 90 triangle. Okay? So we see 20 here, we see 60 degrees here. What should this angle be right here? Should be 90 degrees. What's this one up here going to be? 30. Okay, and the question is how tall is the glass? So if I'm picking between x and y, what do I actually want to solve for, x or y? Y. That's the height of the glass. Okay? So what is x in this 30, 60, 90 triangle? Can you tell me what x is? Or sorry, what's opposite of 30? What's the length of this leg opposite of 30? No, what's the length of the line opposite of 30? 1? No? Okay, so we don't remember our... Here, let's do a better job of drawing this. Okay, if this is 60 and this is 30, somebody said 1, and you're kind of right. The ratio is 1, right? What goes over here? 2, and what goes over here? Radical 3. So if what's opposite of 30 is 1, then the hypotenuse is 2, and then the opposite of 60 is radical 3. But my hypotenuse is not 2. It's 20. So what is the side opposite of 30? 10. You say, well, we're looking for y. Why didn't we just do that? Well, because the easier job is to find that, and then I know that this length over here is what? What? 10 radical 3. Because that's the ratio. Right? So it goes 1, 2, radical 3. So if this was 2, this would be 4, this would be 2 radical 3. Okay, 3, 6, 3 radical 3. Go ahead. Okay, come back over here to our right-hand side. If this is 1, okay, this is my ratio, 1 to 2 to radical 3, always. Okay, so 30, okay, 1. 60, radical 3, 90, 2. Okay? But imagine it more like this, if we had to, because we're changing the numbers. X radical 3, 2x. Okay? So if I know what's opposite of 90 is 2x, then we're saying 2x in this case equals 20. Can I solve for x? Okay? What is x if 2x equals 20? 10, right? So x equals 10. And if x equals 10, then 60 is 10 radical 3. Does that help out at all? Okay? Now, there is another way to solve this if you remember your trig function. So let's come back to this here for a second. Let's say I can't remember my ratios. Those don't ring a bell. Okay, we do still have a right triangle, correct? All right, and we just got done with a whole bunch of SMART goals talking about trig functions. So if I'm looking for this, all right, then it probably won't even ring again. Nope, ring again. Okay. Okay, so we're looking for x, which means I can honestly I can pick either angle. Okay, let's say that we wanted to go from 60, right, and use 60 for my angle. What is x in relation to my 60-degree angle here? Opposite, and what is 20? Hypotenuse. What trig function uses opposite and hypotenuse? Sine. So we would say sine 60 equals x over 20. So what I would end up writing is 20 sine 60, right? Well, what is 20 sine 60? Okay, well, what is 10 radical 3? Because that's what we determined we'd get. Is that the same decimal? Yeah, comes out to the same thing. Okay? Now you say, well, what if I didn't use 60? Could I use my 30-degree angle? Yeah. Okay? What is x in relation to 30? Adjacent, and that's still hypotenuse, so that would be cosine 60 equals x, adjacent, over hypotenuse, or 20 cosine 60. Try that out. What's 20 cosine 60? Is it the same number? Is it? Yeah, it's the same number. Okay? So 10 radical 3 is the same as 20 sine 60 is the same as 20 cosine 60. Okay? Oh, I'm sorry. This shouldn't have been 60. That should have been 30. My bad. Because that's a 30-degree angle. Okay. You're giving me a look, Geneva. And you knew I messed up? Yeah. Okay, and you didn't say anything, so it's on you. Okay. All right. Do we know how to solve this question? No? Okay. Do you understand this over here? Well, don't do this then. If you understand this over here, that's going to be enough. I'm just trying to give more ways for people that don't understand one particular way. Okay? So if you understand this section over here to the right, then just do that. Okay? It'll work for a 30, 60, 90. And you're going to get a 30, 60, 90 question on the test. Okay? And it'll be pretty similar. It'll be real similar, actually. Okay. Number 6. How many questions are on the review? 20? Okay. Number 6. We said number 6 was on our list? No. But you will notice that it's really similar to question number 2. So it's good practice for us, right? What was my equation? A equals P. Okay. All right, so question number 6 says a savings account earns interest at an annual rate of 4%, compounded semi-annually if the account begins with a principal amount of $1,000. So do I know what A is? No. Do I know what P is? 1,000, right? Okay. Then I still have 1. What's my rate? 0.04. Compounded semi-annually. How many times a year is that? 2 times. 2 times. Okay? So 2 times how many years? 8 years. All right? So we got 1,000. We got 0.04 divided by 2 plus 1. Okay. What's that, like 1.02? Is that right? To the 16th. So I'm going to take 1.02 to the 16th times. And I get 1372 point what? 0.79. Okay, number 6, 1372.79. Okay, so that's just a little bit of extra practice. Doesn't hurt. Number 7. Is number 7 on our list? No. Okay. But let's talk about it. One fair coin is flipped 4 times. Find the probability that the coin comes up heads each time. Okay. Well, there is a long way of doing this. If we flip a coin 4 times, we can get heads, 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 right? Okay. Or we can get heads, 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 tails, right? Or I can get heads, heads, tails, heads. I can get heads, tails, heads, heads. I can get tails, heads, 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 right? And that's every case where tail shows up 1 time, right? And heads all, every time. We can get heads, heads, tails, tails. We can get heads, tails, heads, tails. All right, we start to find out that there are several different combinations, correct? Okay. Let's see, I'm trying to think of what the easy solution is on this. Okay. We should find that there are approximately 16 combinations. All right, so what you're coming up with is 1/2 to the 4th. Okay, because you'll notice there's only going to be 1 time in here where I'm going to get heads all 4 times, right? It's only 1 probability. All right, we just have to find out what the total is. So 1 to the 4th is 1. What's 2 to the 4th? Anybody? 16. All right, so there's a 1 in 16 chance. What we would end up with is if we drew all of these out, we would find that there are 16 different scenarios, and only one of them is heads all 4 times. Okay? Does that make sense? All right. You guys out of here at 36. All right, let's see what question number 8 looks like. For some reason, I don't even see it on my paper. It's like it snuck out somewhere. Did I list number 8? No. I don't see number 9 either. Huh? My paper goes 1, 2, 3, 4, 5, 6. Oh, hold on. I see 8 and 9. Number 8 is actually a good question. Number 8, put it on your list. Okay, we may not get it covered today, but we do need to cover number 8. So put it on your list. That's actually going to fill in a gap on one of the 3 that I didn't have a number for. Okay? All right, so we will stop right there. We'll count this as part 1, and I'll try to get video stuff out to you.